Welcome to lesson 7.2, Similar Polygons. Today we're going to be talking about similarity, which is one of those topics in geometry that is so important to understanding geometry. I'm just excited to get into it. So let's just start with what the definition of similarity means. What does it mean when polygons are similar? Well, polygons are similar if they are the same shape, all right? If they have the same shape, but they're different sizes, all right? Same shape but different sizes. So that makes sense, like they're not congruent because they're different sizes, but they're the same shape, so they're pretty close, right? They're pretty close. You might say that they're even similar. Huh? Yeah? Makes sense. Makes sense. So I want you, based on this definition, to figure out which set of triangles here would be considered similar. Take a minute and think about it. Okay, well, if you said that these two are similar, you would be 100% correct. These are our similar triangles. And why? Because look, they are the same exact shape, except one's bigger than the other one. It's like if you inflated this one and made it bigger, it would come out like this. So the same shape, different sizes. These two would not be similar, right? Because even though they're both triangles, the way they're shaped is different, right? This is kind of to the left, this one's like not leaning to the left, so they're not exactly similar. All right? So similar, same shape, different sizes. Not similar, not the same shape. So what are the properties of similar polygons? Okay, there's two properties that you need to know about similar polygons. Okay? So let's say we knew this. Triangle ROB is similar to triangle FAT. And this symbol right here, this little wavy sign, that means similar. Okay? So if we knew triangle ROB is similar to FAT, the first thing we know is that the angles are congruent. The angles are congruent. In all similar triangles, all the angles are congruent. And so in this case, I would know that R is congruent to F, and not just because they look about the same, right? But because if you remember from congruent triangles, these are in order. R is the first letter and F is the first letter, so these are congruent to each other. So R is congruent to F. Furthermore, we know that O is congruent to A. So O is the second letter, so that's congruent to A because that's also the second letter. And we know B is congruent to T because that is our last letter. B is congruent to T. So the first property we know about similar triangles is that the angles are congruent, okay? And that this order of these letters does matter. Don't forget that. Now the second property we know is that the ratio of each sides, the ratio of the sides is the same. All right? The ratio of the sides is the same. Now, what do I mean by that? Well, let me tell you this. The ratio of RB to FT, all right, the ratio of these two sides would be the same as the ratio as OR is to AF, all right, is the same ratio as OR as to AF. And that's the same ratio as OB is to AT. OB, sorry, is to AT. Oh. Now, this is kind of hard to visualize, so I think it might be easier if we put some numbers in there, right? So let's put it this way. If I know RB is 8, all right, and FT is 4, the ratio would be 8 to 4, right? And that would just be a ratio of 2 to 1 if we simplify it, right? You can put that in the calculator. Simplify it, that's a ratio of 2 to 1. Now, the ratios have to all be the same. So if I knew that this side was 10, all right, if I know OR is 10, what would FA have to be? Well, that's right, it'd be 5, right? Because the ratio is 2 to 1. So 10 to 5, which is 2 to 1. So our ratios are the same. And finally, our last ratio, if we knew this was 12, what would AT have to be? Well, this would also have to be 6, right? Because that is a ratio of 2 to 1. So the ratio of all of these sides needs to be the same, all right? And that is the second property of similar triangles. 8 to 4, 10 to 5, and 12 to 6, right? So basically, half of all these numbers. You cannot have it so they have different ratios, right? So I couldn't just put, this would be a ratio of 10 to 7, 8 to 7, and this is 10 to 5. That doesn't make sense because they're not all the same then. And those are two properties. Now let's use those two properties to solve some problems. Okay, so we know triangle CAT is similar to triangle DOG. Fill in the missing angles of triangle DOG. All right, well, we should start by finding all the angles of CAT, right? So we know two of them. This one's 90, angle C is 90, and angle A is 32, but we don't know T. Now, how are we going to find out T? Think back. That's right. We just take away 90 and 32 from 180. All right, and that gives us 58 degrees. So angle T is 58 degrees. Now, to figure out what the angles in DOG are, we just have to remember that these are in order, right? So angle C is congruent to angle D. So since C is 90, we know D is also 90 degrees. And we'll just put the right angle there. Second, we know A is going to be congruent to O. So A is going to be congruent to O. So this is also going to be 32 degrees. And finally, T is going to be congruent to G. All right, our T guy over here is going to be congruent to G. And so this will also be 58. And that's it. We know all these angles are equal to each other because they are similar and these angles are in the same position. So angle C must be congruent to angle D because those are in the same position as each other. They're both first. So that was the first property, right? That corresponding angles are congruent. Now this is the second property of similarity, that all sides have the same ratio. All right? Another way to say it is that they're proportional. Like the last lesson. See how it's all coming together? Let's solve this problem. Triangle BIG is similar to triangle LUV. What is the length of UV? Now we don't know what UV is, so let's put an X there. When we don't know something, we like putting X's. Now the second thing to do is to set up your ratios, okay? And let me tell you this. I see that the smallest side of BIG, the ratio of the smallest side of BIG to the smallest side of LUV is 10 to 5. The smallest side of BIG to the smallest side of LUV. Now, as a little convention, all right, what we're going to do is always put the bigger triangle on top and the smaller triangle on the bottom, okay? So this will always be the bigger triangle, always on top, and we're always going to put the smaller triangle on the bottom, all right, every time. So it's 10 to 5. So now we want to set up our next ratio, right? And we know that IG corresponds to UV, okay? So the bigger triangle is 14, and that's over X, all right? We're trying to find out what X is. Now to solve this, you might remember from our last lesson, we just have to do some cross multiplying, all right? Just do a little cross multiplication. So 10 times X is 10X. 5 times 14 is 70. To solve for X, we're just going to divide both sides by 10, and we get X is equal to 7. Now let's see if that makes sense. Well, 5 is half of 10, right? So that ratio makes sense to us. And then 7 is half of 14, so the ratios are the same. We did it! We're so smart. Second one. Rectangle ALIO is similar to SMTH. Remember, that's a similar symbol. What is the length of AO? So once again, I'm just going to put an X there to save my spot. And then I'm going to start setting up some ratios. Well, in this case, it looks like LIA, that's the bigger side. All right, the ratio of LA to MS is going to be 12 to 8. That ratio is going to be the same as the ratio of AO to SH, which is X over 6. Now I want you to recognize, remember, this is the bigger side over the smaller side, and once again, this has to be the same. This is the bigger side. Remember, AO is part of the bigger rectangle over the smaller rectangle. All right, 12 is to 8 is the same thing as x is to 6. Now that we set up a ratio, that's kind of the hard part. We just have to cross multiply. So 12 times 6 is 72. 12 times 6, which is equal to 8 times x. All right. To solve for x, we're just going to divide both sides by 8. And we get x equals 9. Beautiful. All right. So we know this side is going to be 9. Super duper sweet. Okay, moving to our last problem, okay? We know triangle ABC is similar to triangle EDF, okay? ABC is similar to EDF. What is the value of x and the length of FE? So it's asking us two things. What's the value of x and the length of FE? All right? Well, what we have to do now is just once again set up our ratios. If they're similar, we know we should set up our ratio to find the lengths of these sides. So let's do that, okay? We know that the ratio of CA to FE, right, our two shortest sides, is going to be 9, which is part of our bigger triangle, over x minus 1. Okay? And then we can set up our next ratio, and that's this. We know BA is 12 over DE, which is x plus 1. Okay? Now from here we just have to solve. All right? So we're going to cross multiply. 9 times x plus 1 is equal to 12 times x minus 1. Now to solve this, the first thing you do is distribute. Okay? So we're going to distribute the 9 to both of these. So that's 9x plus 9 is equal to, and we're going to distribute again, 12x minus 12. To solve, let's see, I'm going to subtract 9x from both sides. All right. That cancels. I get 9 equals 3x minus 12. I'm going to add 12 to both sides now. So I'm going to add 12, and I get 21 is equal to 3x. Whew. Now to divide by 3, and we get x is equal to, well, 21 divided by 3 is 7. All right, x is equal to 7. We did it. Now to find out what FE is, we just have to plug that in. So FE is equal to x minus 1. So another way to say that is 7 minus 1. Remember, we're just plugging in x. And so FE is equal to 6. Awesome work. Now, that's it for this lesson. You guys are on your own. Just remember, the hard part of this whole lesson is setting up your ratios, all right? So it's always the bigger triangle over the smaller triangle. And you have to use the corresponding sides. You can't just guess randomly. You know, 12 is to 8, right? Because these are both the longer sides. Couldn't say 12 is to 6. That just doesn't make sense. Because this is the bigger side, that's the smaller side. You don't set them equal to each other. Don't do that. All right, I'm done. I'm sorry, I'm getting a little worked up there. So, have a very merry day, and try to help one old person today. It'll make you feel good. All right, peace out.